In 1993, Sega made their sequel shorter and left my MegaDrive hanging. Hello all and welcome to the corner. I have the Sega MegaCD 2 on the table today, called the Sega CD in America. The sequel to the original MegaCD and Sega CD, the MegaCD 2 shifted to the right, ditched the tray loading drive, but most importantly left you unable to ever know if it was truly ready. Also ditched but not as missed was a cable clamp for the audio mixing cable. This cable was required to have the RCAs on the back of the MegaCD output stereo sound from both the MegaDrive as well as MegaCD. This is because the original model MegaDrive could only output mono audio from its AV jack, with stereo only being available on the headphone port on the front, so you would need this mixing cable. The MegaCD 2, however, was clearly designed to match the also recently released MegaDrive 2, and this version didn't share the same monaural limitation as its predecessor, so no mixing cable and thus cable clamp was actually needed. Attaching the MegaDrive to the MegaCD involves the use of two metal joiners. One press fits into the bottom grills of the casing and touches the RF shielding inside the MegaDrive. This allows a direct connection between the joining plate and the MegaDrive's internal shielding. The joining plates differ between the MegaCD and the MegaCD 2 but do the same job, which is to clamp the two units securely together and provide good shielding. Once slid into place, a singular screw is tightened to fasten the plate to the MegaDrive, and after removing the expansion cover, it's now ready to be attached. The MegaDrive then slots into the right of the MegaCD with a resounding clunk. My original model MegaDrive overhangs, which is why Sega would supply a plastic extension piece to fix this cosmetic issue. But as this unit is on loan, I don't have this piece. However, it would attach here with a screw. Now we've had a general look around, let's plug it in and see what's going on. This BIOS screen is just screaming to show you that the MegaDrive can now do Mode 7 graphics. After all, you'd want it to after paying £270 or $300 for this unit. Anyway, let's try playing Konami's Lethal Enforcers. It says press start, but the disc hasn't loaded. Maybe this demo disc of Soulstar and Battlecore will work instead. Nope. How about some symphonic metal in the form of Nightwish? No, not even the power of finished metal will make this drive work. However, I did notice this. Take note of the CD's current position. Now when I open the lid, you can see that the CD hasn't moved at all. In fact, you can hear the drive isn't even spinning up. I think it's time we open this unit to see what's going on. There are 6 crosshead screws on the underside that hold this unit together. I'll just keep these safe in this little pot. The top lid comes off nicely and reveals the very dirty and slightly rusty inside. We're going to need to remove this top RF shield, which is another 5 screws in this case. I wonder if the 6th is missing. I'm using a flathead screwdriver here to unclip these prongs that ground the expansion connector so that we can remove the top shield. Now this is very odd looking, but I'm led to believe that this mod board is from the factory, as I've seen other units with it installed too. Attaching the now unsupported MegaDrive, we'll power up the two units again and see what's going on. I'm using the demo CD again and the magnetic clamp from the top lid to hold it in place to see it do, well, really nothing. No spinning at all like we assumed. First thing to try is some CD lens cleaner and a soft cotton bud. Here I'm gently cleaning the top of any dirt or dust, and then I'm using the other end with a softer tip to dry it all off. Let's try that demo disc again. And again, nothing. Though I spun the disc to see if the motor wasn't seized, and clearly it moved, so there must be another issue. Using the camera pointed at the laser module, we can see the infrared laser is shining, so clearly isn't burnt out. What I'm doing here is I'm using the gain adjustment potentiometer to see if we can coerce the laser into working. I found that when doing Xbox 360 laser repairs, this would sometimes cure what would seem to be a failing laser, although it could be just a temporary fix. I'm only making small adjustments here, as I don't know the original spec of the laser, and adjusting it too much will damage it if it's not already bad. I tried moving it in both directions to see if there was any change, but nothing seemed to happen. I'll set it back to the original position and then we'll move on. I decided to remove the drive mechanism next to see if there's any other obvious issues. We know the spindle motor can move freely, so I decided to check for resistance to see if the motor was electrically bad. Setting the multimeter to ohms, I can measure the resistance of the motor, which settles at around 12 ohms. Seeing as the laser seek motor is a similar type, I decided to measure it to see if I could compare the two. At 11 ohms, they're about the same, so the spindle motor should be working fine. I removed the motherboard and wow, that corrosion is really everywhere. I wonder how it got this bad. It might not be so visible on the camera, but the rear section of this board is covered with a black filth, almost like soot if it came through the I/O port holes. Whilst we're here, I decided to measure the internal SRAM battery. And yep, unsurprisingly, it's completely dead, and just reading over half a volt. Here I tried to see if isopropyl alcohol would clean off the black dirt around the board, and you can see how much of a contrast there is between the cleaned and uncleaned areas, so the board will need cleaning, as I don't know whether this will cause damage over time if left. At this point I was trying to figure out what would be stopping the drive from spinning discs. It could still be the laser diode, but there is one other option I could try first, and for that we need to go to the soldering bench. I decided I would try to recap the motherboard to see if any change would be made, as I had all the required capacitors to do such, and it wouldn't cause any harm in doing so. Now, although most people would usually replace all the capacitors on the motherboard, I won't be doing that in this case, and I'll explain why in a minute. Here are the capacitors for the CD drive, which is used for smoothing voltages for the drive controllers and such. These capacitors down here are mostly for the audio mixing section, including the PCM CD audio drive output and for mixing the MegaDrive's audio into the rear RCA ports. Now if we take a closer look, you can see from the markings that these are Nichicon branded capacitors, and being factory fresh, they're guaranteed to be original. The capacitors I have with me today are of dubious quality, with a brand name that doesn't instill any confidence. Because I trust the Nichicons aren't actually bad and the audio quality can make a huge difference when you mess with the circuit, I'm leaving the audio section alone. I also won't be changing the input filter capacitors except to the drive motor controller, as they wouldn't cause total spindle failure either. All of the electrolytic capacitors are through-hole and have their leads bent around the pad to hold them in for manufacturing. This spudger is what I thought might be needed to lift the leads after melting the solder to allow the capacitors to be removed easily. Now, although I don't show it on all capacitors, I did mark the undersides of the ones I was changing so I could change groups of capacitors with the same values at the same time. With all of that said, we can start the montage. Here you can see me using the spudger on the leads. I can use it like this because the solder won't stick to the metal as it's stainless steel. And whilst this did work, it might not have been the best option, as you'll see later. I actually found it easier to heat the legs of the capacitors and then rock them side to side to slowly remove them going forward. When clearing the solder from the holes, I had to switch between using a desoldering braid and using a desoldering pump. Sometimes one worked better than the other, but each had their own drawbacks. You can see on this side of the PCB that these capacitors are polarised. They can only be installed in one way or they could explode. This plus symbol marks the anode or the positive side. The longer lead on the capacitor is the anode or the positive side. The negative stripe on this side of the casing points to the shorter leg, which is the cathode or the negative side. They also bend the legs to hold them in place and keep a similar factory look. When using desoldering braid, you want to occasionally cut off the excess, otherwise it acts like a heatsink and takes heat away from the iron. I don't know if it's because my iron was too hot, the PCB is aging, the leads are still partially soldered, or just the tools I was using were just too rough, but some of the pads were damaged when removing the capacitors. They soldered fine afterwards, but with any old electronics you should always be careful or you might cause yourself more problems down the line. I realised too late that I didn't have any 0.47 microfarad capacitors to replace these with. I could probably use 1 microfarad capacitors instead, but to be safe I'll just reuse the originals and they're probably fine anyway. I just need to clean the leads of excess solder and straighten the legs up again. Here the bottom pads were pulled off from one capacitor, which I then had to clear the holes and then solder the new capacitor from the top side. That's the caps done. Let's remove that old battery. Using a similar rocking technique, I used the spudger to apply a little pressure while heating the pads. Now it's out and it looks like it was starting to corrode on the underside. We might have caught this just in time. I haven't seen a coin cell do this yet, but I suppose it was only a matter of time. Because the MegaCD 2 PCB is at least 4 or more layers and the negative side of the battery attaches to a ground plane, I have to use a heat gun to apply some gentle heat to the area so that the ground plane doesn't act like a heatsink to my iron. You can see again how I keep swapping between using the pump and using the braid. One to remove excess solder and the other to suck up any stray pieces. I'm cleaning the board where the battery will go with isopropyl alcohol, as this is the only time that I can clean that area of the board. Instead of fitting a welded tab battery, I'm replacing it with a CR2032 coin cell holder. This will make changing the battery in future far easier. There's only 2 leads on this battery holder compared to the battery's original 3 leads, and they don't land where the battery pads are, but at this angle the leads fit nicely, and so that's what I'll be doing. And cleaning off any residue flux with isopropyl alcohol and a toothbrush. You should do this as flux can be both slightly conductive and become corrosive over time. Let's put the unit back together enough to see if the capacitors have solved our problem. I must confess, I'm not too surprised to see that it's not changed anything, but it does leave us with the laser as the most likely thing to suspect. Even if we can see it still operating, CD drives are complex pieces of optics and old lasers tend to be a weak spot in them. But that will have to wait for now until I have a new laser to fit to this unit, which will fit in part 2.